For the double displacement reaction, also called a double replacement reaction, we're going to react a solution of potassium thiocyanate with iron 3 sulfate solution. In this type of reaction, the metal cations of each reactant will swap bonding partners. When they react, in this reaction, we form iron 3 thiocyanate, which forms a solid that kind of suspends in solution. The other product being potassium sulfate, which remains dissolved in solution. Double replacement reactions always follow this pattern, where bonding partners swap places with each other. Let's see what this looks like in a more simple diagram. In double displacement reactions, we always have what we can simplify as partner swapping. We have a cation A and a cation C that are bonded to anions B and D. When the reaction proceeds, the cations swap partners with their respective anions. A will then bond with cation D, and C will then bond with cation B. This frequently occurs when cations A and C are metal ions, and anions B and D are frequently polyatomic anions. This isn't always the case, but more often than not, that is the type of reaction you'll see. Let's see how the reaction proceeds in motion. A and C will break apart with their respective anions and swap partners, bonding with the other anions. Let's take a look at the overall simplified reaction and particle diagram. Now let's go ahead and take a look at our actual reaction that was demonstrated with an overall reaction and particle diagram. As is generally the case with the actual reactions, we have to take a look at the balanced reaction, which always consists of the stoichiometric proportions. In this case, we have 6 potassium thiocyanates that react with 1 iron 3 sulfate. Because these are polyatomic anions, we have to remember that they are going to stay grouped together. In this case, we have metal cations, potassium, and iron 3. These are what are going to do the primary movement and swapping with partners. As the reaction progresses and the replacement takes place, there'll be a lot of movement that goes on, but just remember that what's actually happening is the potassium and the iron 3 cations are simply swapping partners and bonding with the other polyatomic ions, the thiocyanate and the sulfates. They'll have to rearrange their proportions so that the stoichiometric ratios remain proper for the reaction to take place. Let's see what this looks like as the reaction proceeds. We can see that all the 6 potassium cations have bonded with the 3 sulfate polyatomic ions, and all of the iron 3 cations have bonded with the 6 thiocyanates. We have performed a double displacement or replacement reaction. Let's take a look at what the overall reaction and particle diagrams look like.